Okay, chapter 7.2, right triangle trigonometry. This is page 5 of the notes. Definitely want to make sure there's some stuff at the top here you are comfortable with, otherwise this page is going to go fairly quickly. So the basic trig functions, the ones that you will find on the calculator and the ones that you need to be super comfortable finding the ratios for, are the sine of theta, cosine of theta, and tangent of theta. And so real quick, just the reminder, the sine of theta is the length of the opposite side over the hypotenuse. And we're going to use our SOHCAHTOA to remember everything. The cosine of theta, the adjacent side over the length of the hypotenuse. And then the tangent of theta, which is going to be the length of the opposite side over the length of the adjacent. Okay. Then it's important that you can match up a trig function with its reciprocal. So again, I mentioned before, an S and a C have to go together. So cosecant is the reciprocal of sine. So we've got the C in cosecant, the S in sine. Secant, and that should be cosine. Fix that. And then cotangent and tangent. I will try to get into the notes and change these up before I put them out to you. There's always a chance that I am going to space that. Okay. Last thing we've got here are what's called our quotient identities. The quotient identities are the trig ratios that can be written as a ratio of two other ratios. So tangent we talked about as opposite over adjacent. It's also the sine of theta over the cosine of theta. Cotangent is the reciprocal of that, so it's cosine theta over sine theta. Okay. So we're going to talk about something just a little bit different. We're going to talk about cofunctions. So exercise 7 there, example 7. A cofunction is a trigonometric function whose value for the complement, you notice the word complement is in blue and underlined. It is a link to a web page that'll give you a definition of a complement if you're unsure of what that is. Okay. So the complement of an angle is equal to the value of a given trigonometric function of the angle itself. So that's super helpful. So let's back up a minute and then we'll take a look at a couple of examples. In a right triangle, the two acute angles are complements of each other because the angle measures add to 90 degrees. So when we talk about cofunctions, we need to be able to use the complements. We need to be comfortable using the complements. Right? So cofunctions, sine and cosine are cofunctions, secant and cosecant are cofunctions, tangent and cotangent. So yeah, it's the co of the function that is the cofunction. So we're going to start off by talking about complements. Remember that the ratio value of a function is going to be equal to the ratio value of the cofunction of the complement. So a complement, two numbers have to add to 90 degrees. So to find the complement of 10, we're going to subtract that from 90, and we get the complement of 10 degrees is 80 degrees. On B, the complement of 80.6, we're going to take our 90 degrees, we're going to subtract 80.6, and we get a complement of 9.4. So the complement of 80.6 degrees is 9.4 degrees. This one, C, looks a little different. We're no longer talking about degrees. We want this in terms of radians. And so important to remember that 90 degrees is pi over 2 radians. So we're going to do the exact same thing we did up top. We're going to take our pi over 2. We're going to subtract our pi over 3. Remember that in order to be able to subtract fractions, we've got to have a common denominator. So we're going to go ahead and work that in. And we get what? 3 pi over 6 minus 2 pi over 6. We end up with the complement of pi over 3 being pi over 6. One more time here. We've got to take pi over 2 and subtract 4 pi over 9. Again, common denominator. So we multiply this one by 9, this one by 2. We get 9 pi over 18 minus 8 pi over 18. Denominator stays the same when we're subtracting fractions. We subtract the numerators, we get 1 pi. So the complement of 4 pi over 9 is 1 pi over 18.